Hello, 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 hello everyone. Welcome back to the channel. So today we will be solving this question called the line empire from the Codeforces. So the question states that. So I'll basically explain the question real quick. So yes, uh, this is position 0, this is position x1, this is position x2, this is position x3. Okay, why is this down? 0. Okay, 0. And x1, x2, x3, x4. So on up to xn minus 1 and xn. Okay, so here you are basically a king in the story, and first you have conquered only this position, okay, only this kingdom, and here lies your capital. Okay, here lies your capital, and you want to conquer all these things. Okay, you want to conquer all these things up to xn, and you cannot jump. Like if you have conquered 0 and if you want to conquer x2, then first you have to conquer x1, then only you can go to x2. Okay, so that is the thing. And cost, there's a cost involved to conquer a kingdom. So that cost is b times, uh, suppose your capital as is at 0, so the cost involved is b into x1 minus 0. And one more thing, you can basically shift your capital. Suppose if you have conquered x3, then you can shift your capital there, or to x2 or to x1. Basically you can shift your capital to the places which you have conquered. Okay, so if your capital is at x3 and you have conquered till x5, and you want to conquer x6 which is not yet conquered, then you will incur a cost which is b into x6 minus x3. And if you want to move the capital from, suppose, x1 to x3, then you will incur a cost a into x3 minus x1. Okay, so this is basically the thing. And you can guess that n comma a comma b, and these x1 less than x2 less than x3, so on up to xn minus 1 and xn will be given as input. Okay, so these things will be given as input, and we need to find the minimum cost. Okay, so the minimum cost to conquer everything. Okay, uh, sounds like a dream, right? Conquer everything. Anyway, so conquer everything. So this is basically the question. And uh, suppose if the constraints were by chance small, suppose uh, you would say n was up to 1000 maybe, then you would have written O of n square solution, right? So dp solution, basically. How dp solution? So you will make dp of I comma j as something like uh, so basically you want to conquer till the ith index. Okay, so you have conquired minimum cost. Okay, let's be formal. Minimum cost required if we want to conquer all the kingdoms, till I. Okay, till I. And finally, if your capital, and finally if your capital lies at jth index. Okay, so this will this is something that our dp will signify. And from moving from I to I plus 1, okay, so you can basically move and not shift the capital. Okay, you will move and not shift the capital to the I plus 1th index. Okay, capital. And you will go from I to I plus 1. You will move, means firstly you should conquer it and do shift the capital. Okay, for the further references. Okay, and finally your answer will be minimum of all the things, what all the dp of, suppose we assume the zero based indexing, so dp of n minus 1 and j, so for all j belonging to 0 to n minus 1, right? So basically not n minus 1, so if you think cleverly, it is basically j belongs to 0 to n minus 2, right? So not this thing. Okay, because if you, okay, I wanted this pen. Okay, so if you conquer the last capital, okay, if you conquer the capital at index n minus 1, then basically you're done, right? You don't have to shift your capital there, right? So basically j belongs to 0 to n minus 2. So in this case, O of n square solution would have been accepted, or you can say fit in the time limit. But as you know, wait, it is all about optimizations. So you see here that n is up to 2 into 10 to the power of 5. Okay, so we know this solution won't fit in the time limit, so this is a valid solution. Just you have to find some bottleneck to catch and, you know, just improve your solution drastically. So you can say O of n or O of n log n solution should work, right? So let's see how it goes. So what I can notice is that, suppose I will fix, suppose my capital will end at some index I. My capital will end at some index I. Okay, so if my capital will end at some index I, then basically suppose it is ending at index I when I conquer all the kingdoms. So basically in the process I have to take it from 0 to I, right? So I can, how can I take it from 0 to I? So listen, you can directly jump 0 to I, or you can jump through some states. So you go to, suppose, some index j1, then go to j2, then j3. So these are basically the indexes lying between 0 to I, both exclusive. So j3, so on up to I. So these are the two ways that you can achieve this. Okay, so what I can notice here is that, so in first case, this is the first case, and this may okay, this, let this be the second case. So listen. So so if you want to go this way, so suppose 0 1 2 3 and so on up to I minus 1, I, assuming that this I plus 1 fits into the constraints of less than or equal to n, so on up to n minus 1, n minus, okay, n minus, let me take here n minus 2, n minus 1 and n. So if you want to directly jump from here to here, so basically this process requires two types of costs, right? Two types of costs. So first is move the capital, move the cap city, and second is conquer the kingdoms. Okay, conquer the kingdoms, right? So basically, uh, this when can I shift the capital to the Ayat city? Only after I have conquered it, right? So uh, let's suppose you go the first way, and after conquering only you go there, right? So what I can notice is here is that moving the capital city from 0 to I incurs the cost, which is a into v of I. Okay, not v of I, basically xi minus 0, right? So this is basically the cost incurred if you go by first step, right? You go by first step, right? And what about second one? So yeah, so suppose you jump from, what you can say, you jump to some xj1 from 0 to xj1, then xj2, then xj3, and so on up to, okay, what, xj r, and then you jump to xi. Okay, so what is cost incurred here? So in the first step from 0 to xi, you will incur a into xj1 minus 0, plus in second step, in this step you will incur a into xj2 minus xj1, right? Okay, now what about this step? So you will incur a into xj3 minus xj2, and so on up. This cycle will continue till a into xjr minus xjr minus 1 plus a into xi minus xjr. Okay, so basically you can notice here is that, okay, this 0 vanishes, so this thing cancels out. Okay, nice use of this red pen though. This cancels out with this thing. Okay, this cancels out with this thing, this cancels out with some this thing. So basically you will notice that this cancels out with this thing, and this will be all already cancelled out by here. Element will be there, right? X j, what will be it, j r minus 1 minus x j r minus 2, right? So this will vanish. Okay, this will neutralize this thing. So finally what you are left with, it is basically a into xi. uh, is this same in the first case? Yes, it is basically a into xi. So basically you can say that these numbers don't matter, means these indices, how you shift them directly or through whatever arbitrary indices xj1, j1, j2, j3, or whatever it is. So we cannot minimize this thing, right? First step, moving the capital city to the ith index. But what we can optimize or can minimize is this conquiring the kingdoms part. Okay, so what you can notice here is that, so if you were on 0 in this first case, okay, the first case is that directly shifting, okay, direct shift when you conquer the ith city. Okay, so when you wanted to conquer 3, okay, you conquered from 1 1 2, and you come to conquer 3. So basically in the first case you will need b into x3 minus 0, right? And to conquer 4 you need b into x4 minus x3. Okay, so this is no, okay, not x3, not x3. So sorry for that, you will require b into x4 minus 0. So what about the second case? Okay, let's look at the second case. Is this too small? Uh, So basically in the second case you can see that when you shift the capital to suppose second index, okay, so to conquer the uh, kingdom which is on third index, you will basically need b into x3 minus x2, which is definitely less than or equal to b, okay, not less than or equal to, strictly less than x3 minus 0, right? So again, if you conquer 3 and move your capital there, so to conquer x4 you will need x4 minus x3, right? Because you have shifted the capital to 3, because it adds no overhead, right? Because in case 1 we have seen that moving the capital city won't add extra overhead to our cost, so this is definitely less than x4 minus 0, right? So can I write the linear O of n solution, linear time solution? Yes, basically I can. Okay, so how can I write it? So basically I will run a for loop from you can say 0 to n. So I will say that my capital remains at this index from I to I, from 0 to n. I will run a loop and I will fix my capital to that ith city, okay, and then calculate the cost involved, okay. So how can I do it? So basically, suppose you are at zeroth index in initially, first index, second index, third index, fourth index, fifth index. So this is your capital city cap. Okay, it is at 0. So basically, you determine that okay, my capital city is going to be at 0 only. I am not going to touch it. So in this case, your answer is gonna be, or not answer, okay, not answer, your cost is gonna be uh, you can say b into x1 minus 0 plus b into x2 minus 0 plus b into x3 minus 0, so on up to, without okay, I don't know, it is okay, anyway. So let us suppose there are 5 indices only, so b of x5 minus 0, right? So this is basically b into summation of all xi's, right? So I is equal to 1 to 5. So this is basically the prefix sum till this index, right? So this thing, so you want to add all these and then multiply with b, okay, so multiply with b, so that will be your cost. So you just so in the second iteration of for loop, you determine that my capital is gonna be at 1, okay. So what costs will you incur? So first of all, you will incur a cost to win that kingdom. Then okay, sorry, B for winning, right? Winning the kingdom or conquering the kingdom. You will first conquer it and then set a capital there, right? Okay, sounds cool. And then you have capital here. Okay, let's move the capital. Let's get the feel of it. Capital. We have moved the capital. So now you want to conquer this thing, this thing, this thing, and this thing. So b into x2 minus x1 plus b into x3 minus x1, so on up to b into x5 minus x1, okay. So I should have written this in blue anyways. So it will be a plus b into x1 plus b into, what you can say here, b into sigma I is equal to 1 to 5. Okay, let's go step by step. I is equal to 2 to 5. xi minus mm, okay, xi minus x1. Okay, so this is basically the thing. So can you write it as plus b into sigma I is equal to 2 to, okay, not 2, 1, 1 to 5 xi minus xi minus b into b into 4 times x1. So how this 4 came into play? N minus the index on which capital is. Okay, so this is basically this 4 doing. Is it fine, or we have to subtract something? Minus 4 x1, and also we have to subtract this thing x1 also, right? Yes. So this will be my cost. What about capital at city 2? Then it will be, so this is the cost. So let gaze here, this is the cost to move the city, move the capital to x1, right? Okay, so what will be the cost of moving, conquering and then moving the capital till x2? So it will be a plus b into x1 plus x2. Okay, so this is the thing. Then again b into sigma I is equal to 2 to 5 xi minus b into 3 into x2 here. Okay, so remember you have moved capital to x2, and again you have to negate the running sum here. Okay, why running sum? Running sum is the prefix sum of that thing. Why? Because you should uh, I think you have got that idea why running sum, but if you have not, you should dry run one simple test case, make a simple test case for you and dry run it for yourself for n is equal to 3 or some small values, and you'll know why running sum. So basically if I want to explain why running sum is that, so when, so basically you are not taking, so when your capital city is at 2, okay, not n minus 1, right? It should be n. Okay, so if your capital is at 2, uh, you incur all the costs like this thing, this thing, this thing, this thing, and this thing, but you basically ignore these costs, right, to conquer them, because already you have conquered them here and made them as your capital, right? So that's why running sum, if you are at 3, you will ignore all these things, right? Okay, so you'll start from here, then there, and then there, then you'll go here. Okay, so that's why running sum is mentioned here. So I think you have started noticing a pattern. So when capital is at 3, then cost will be a plus b into running sum, you can say x1 plus x2 plus x3 plus b times sigma I is equal to 3 to 5 xi minus b times, okay, wait, n minus 3, so it should be 2 into x3. Now capital is at 3 minus the running sum till the third index, right? So yeah, so are you convinced that we can do this in O of n time, right? So let us head towards the code. Okay, so basically too many things that have to be done in one for loop. Okay, yes, so basically initializing and using zero based indexing. This sum is the prefix sum till the last index. Okay, so sum is basically the uh, addition of all the values x1 x2 x3 and all. So initializing answer with b star sum. So yeah, where is it? So b star sum, initializing it with this, and then this is temp is for this thing. You can say temp is made reserved for this thing, conquiring and setting capital at the ith index. So this thing is taken care by temp. Okay, this thing is taken care by temp, this thing is taken care by temp is doing nothing, just it is taken care of this thing only. So the further formula I will explain what how the code is, what you can say, there's a word, really nice word, manifesting. Okay, yes, I remember it. So the code is how the code is manifesting the further logic. I'll show you. So basically this is again conquiring and setting the capital at that place, then running sum plus is equal to v of I, and this, you know, b star sum minus v of I. V of I, you know why v of I, right? So this is v of I, this is whole sum, and these two are multiplied with b, right? These two are multiplied with b, and this 2 is taken care with n minus counter. Okay, n minus counter. Okay, so it would have been sufficient if I didn't what you can say, if I didn't keep this counter and just manipulated it using this index I only. But anyways, no problem. So temp plus is equal to that thing, temp minus is equal to b star running sum. Okay, okay, I missed this thing, right? B star running sum. So basically b star running sum, why b star running sum? Because you are neglecting that cost, right? So cost is b star, the whatever it is, x j minus x I, right? So b is missing, so b star running sum, and yes, so b star running sum and counter plus plus updating answer if we get anything less than that in our variable temp. And finally this HMM, or you can say variable, is basically what is it doing? So it is keeping the track of uh, HMM, so basically this thing, right? uh, Increasing it step by step. So that is it. Okay, wait. So sorry, and here also it won't be x1 plus x2 plus x3, right? uh, it will be a plus b into x3. Okay, it will be a plus b into x3. Here also it will be a plus b into x2, x2 only. Okay, so basically this thing you see here, v of I minus v of I minus 1, is basically doing the trick. What trick? It is doing telescopic cancellation. What you can say here is that v of 2 minus v of 1, v of 3 minus v of 2, v of 4 minus v of 3, so on up to v of n minus 1. Okay, sorry, v of n minus v of n minus 1. So okay, sorry for the disturbance. So we were looking at telescopic cancellation. So this cancels, this thing cancels down, so on up to this thing cancels down, and it boils to v of n minus v of 1. Okay, so this is the telescopic cancellation, and this thing is taking care of that. So yeah, this is the code, and then finally outputting the answer. So it passed nicely. in the designated time limit and didn't get any wrong answer as well. So hope you enjoyed solving this nice little problem. So I got it from this TLE Eliminators CP sheet. So try checking that out. It contains really nice problems. And yeah, hope you enjoyed solving this question and listening to the solution as well. uh, Thank you for watching the video. Consider liking the video and staying subscribed to the channel. See you again.